Hello, your next challenge in the 7 Caillou series is called Square Every Digit. Welcome, in this kata you're asked to square every digit of a number and concatenate them. For example, if we run 9,119 through the function, then you get 811,181 to come out because 9 squared is 81 and 1 squared is 1. Note the function accepts an integer and returns an integer. Yeah, we know that. We know how to read method signatures, right? It accepts as parameters an integer, and the return type precedes the method name. So we know it returns an integer. Okay, you guys can handle this, you gals too. Go ahead and pause it, and come on back when you're ready. So, how are we going to do this? I'm going to essentially create a local string variable, and then I'm going to start with the number passed in, and I'm going to peel off the least significant digit each time, and I'm going to square it, and I'm going to put it at the front of the string. I don't want to put it at the back of the string because then our result will come out in reverse order, and you could at the very end call reverse, but if you can avoid that extra call, why not do it, right? We want to do this in the least amount of work possible. So let's create a string called result, and I'm doing a string just so I can simply concatenate the numbers to each other, right? I can't do that with regular integers unless I weight them properly, and I don't want to go down that road. So I'm going to do it this way. I'll have this variable, and then I can make a while loop, and I'm essentially going to process this integer while it has digits for me to grab from it. And so to get that least significant digit, I'll call it val, and I'll say that is equal to n modulo 10. And so if you don't understand why this works, consider a number like 123, right? If you run modulo 10 on it, it's going to divide by 10 and give you the remainder. In this case, 123 divided by 10 would be 12 with a remainder of 3. Well, we want that 3, right? We're grabbing this first digit, and then eventually we'll grab the next one and the next one. But for now, we want the 3. So you can see how that modulo 10 comes up with the 3 that we need. And so I said for the result, I set it equal to result insert. And I'm using this insert. Remember, I'm not using the plus equals like you often do when you concatenate strings. I want to, instead of attaching mine to the end, I want to attach it at the front. So that's why I'm overwriting the value of result with this new value that I keep putting at the front of the string. So and then the idea is, okay, so what do we insert here? We can't just take the value to string, we want the square, right? And we know from recent videos that you can do powers. I mean, you could say val times val if you want, that's fine. I'll use math pow. In this case, val, I'll use 2.0. This takes doubles, right? Remember that. It takes 2 double values, the base and the power. So to square something, it's like raising it to the power 2, right? So we've got that. That will square our value, and then remember it's a double here. So I'm going to convert this result to a string because we're attaching it, right? We're inserting it at the front of a string. So I'm going to make it a string so they match. Okay, we got what we needed, but very important, we've got to update. If we don't update the value of n, then we're going to be stuck in this infinite loop, right? Imagine if I just kept going, n would never change. And it would be that if we're going with the 123, it would stay there. 123 is always greater than 0, so you kind of fall into this infinite loop, and that's not good. So remember, each time we're going to say n n equals n divided by 10. And that's sort of the shorthand for that. So there, I think we're good. Imagine that then with the 123 example, when I divide by 10, I'm going to get that 12, the value of 12. So now it comes down to 12. And you can imagine when we come back up, 12 is greater than 0. It's going to grab the least significant digit again by taking the modulo 10. 12 modulo 10 is 2, right? That's the digit we want. So you can kind of step through that if you want to see how it works. And of course, by the time this is all done, results should have been built up. And but we need to put it back into integer form, right? Our method contracts as integer. They're not looking for the string. So let's return. I think we've seen the convert class in this series. If not, go ahead and look that up on the document page. There are various ways to convert. You know, it's not just int32. There's different size integers. You can convert to doubles and other things. So we'll put result in there, and this will effectively transform the result from its string format into an integer, and that will match the return type. So put that in. String insert, no. Formal parameter. Oh, sure. I see what I did. So it wouldn't hurt to look at the doc page for insert. That'll be a big clue on what I did wrong there. I only had one argument passed in, and it was the new value. That's pretty ridiculous, right? I didn't even say where to insert it. So the first parameter should be where to insert. I'm doing mine at the beginning, but this method is nice and flexible. You wouldn't necessarily have to insert there. You can insert in the middle, however you want. So let's try that. That makes much more sense. Okay, input string was not in a correct format. Stack traits. Let's see what we did wrong here. Oh, yeah. Okay. I see one problem that we did based on the tests. Check out this test. So, well, before I even address this, you're going to run into problems like this when you're erroring out, right? And sometimes they're helpful messages, sometimes they're not. So what you want to do is let's put in some debug statements just to try and give us an idea of what's going on. So we could say console right line, and we could say input was, and we want to see what it was before we started, right? Because I'm sort of modifying it in the while loop. So we know what the initial problem was, and then we could add another one in here, right? We could say if we want to see what the result was changed to, you could do this. We probably were curious what val came out to be, just to make sure we had that right. And maybe you want to know what n was. Okay. And so I'm hoping this gives us a little bit more information. Right. So look, we can see that it was working with this first test, right? The 9,119. We were actually, you can see the iterations there kind of stepping through and building the result. But then we get to this part where input was 0, and we don't see it calculating any result or val or n, right? And that's your clue. It's not executing any of this code. And why would that be? Well, the input was 0. Our while loop says n greater than 0. So yeah, easy to miss. Before we even get into any heavy lifting, why don't we just say if n equals 0, return 0, right? That should be, if you square 0, it's 0. Let's see if that solves our problems. And there you go. See, yeah, I missed an edge case. That's common to do. It's good to try and build up your brain to think of those oddball cases that throw a wrench in your normal thinking. So before we call it, let's make sure we're good here too. Good. And you can see that your print statements if you wanted. This is helpful sometimes too if you don't fully understand how the code's working and you just want to see how values update. That can be very useful. A lot of times I don't do that, but I want to make sure you know how to do that if you run into trouble. So I'm going to clean mine up because you don't really want those debug statements. They're not good for anything when you're, you know, for your production code. It's just noise. And I think we've figured it out, so there we have it. We should be good. Oh, you know what? OCD, let me get rid of that comment. Didn't even make sense. Okay, let's attempt again. Good. I'm going to submit and collect my points and then do the usual scan. See what kind of things other people do. Get some ideas to put in the old toolbox, right? Squares. Okay, sure, yeah. Just grab the digits as you're sort of converting the input to a string and then examining each character. And then from the character, you're sort of parsing an integer. You're pulling it, converting it into an integer. You're squaring it, and then adding that to the output. And with the concatenation, I guess it can take the integer and convert that on its own. And then, yeah, finally taking that string and returning an integer. So yeah, that's a little bit different. Cool. There you go. There's some link stuff. Some new ideas for methods that you might want to look at. Concat. More link. It's kind of nice when they write it out. I mean, it depends on your taste, but it can be a little more readable when you got bits on each line instead of, you know, you make these monster ones. Where I really don't like these is when they don't fit on the width of the screen and you have to scroll left and right. That's pretty bad. They used a string builder down here. String builder's more efficient when you have to manipulate a string a lot, so that's something to keep in mind if you're working with big strings or making lots of changes to a string. Good thing to look into. So yeah, feel free to peruse those. Otherwise, hit me up with questions. I appreciate the likes, everyone. So thank you for that, and thanks for watching.